So yesterday we were solving systems of equations by graphing, and that's what we just spent a big chunk of time reviewing. Today we're going to learn how to solve a system algebraically, not by graphing. And this is actually going to be one of the methods that you probably will use the most often because you don't have to spend time doing the graphs. So we're going to just talk about the substitution method today and spend all of our time on that. So let me give you the definition. The substitution method is when you solve a system. So you will be solving a system by substituting one value for another. So substituting, I know you guys have learned about this before, but when I'm not here, what happens? So if I'm not going to be here, what happens? Do I just leave you alone without any supervision? No, there's a substitute what? Teacher. Substitutes are teachers, right? Okay, so it's a replacement teacher. Substituting a value is replacing for something else. Or in football, when you substitute players in, one player replaces another, right? Substituting a value is the exact same thing. Something replacing something else. So the example that we're going to use is if I have a system, and I'm just going to give you a very simple example. Y plus x equals 3. And y equals 2x. What this is saying is that y and 2x are the same thing, right? Does everybody agree with that? Y equals 2x means that y and 2x are the same. So what I can do is I can substitute 2x in for y in the other equation. So what would my new equation be? 2x plus x equals 3. Another way that I like to think about this is you guys have all used like Microsoft Word or Google Docs. When you copy and paste something, you highlight it and then you copy it and then you can paste it somewhere else. That's exactly what substituting is. You are copying the 2x and pasting it in for y in the previous equation. But that means the y goes away, right? You're replacing it, okay? So that's what we're going to be doing today to solve equations, or to solve systems of equations. So turn to that page in your notes. So to solve a system of equations using the substitution method, we are going to start by isolating one variable in one of the equations if necessary. So the system might not be set up as nicely as the example that I just gave you, where the variable already says y equals. Sometimes you have to do a little solving first, and we'll do an example like that. Your second step, so after we've gotten x equals something or y equals something, you are going to substitute the expression for the solve variable. So copy and paste it in, okay? The really nice thing about that is in our previous example, so I'm going to go back for a second. In our previous example, on this very last equation that we rewrote, 2x plus x equals 3, what's really convenient that you guys notice about the variables? It's all x's, right? So that's the whole purpose of this. So then we are able to solve for the remaining variable. So that's step 3, is to solve for the remaining variable. But if I'm looking at a graph, I should have an answer that's an x and a y, correct? So then I'm going to substitute my answer back in. And solve for the other variable. So we're going to substitute the found value back into one of the original equations, and guess what? It doesn't matter which, and solve. And then these are actually graphs, so my answer should be an x comma y, which is an ordered pair. So then you want to make sure that you always write your answer as an ordered pair, with parentheses, with a comma separating them. Okay? Everybody good? So let's actually do number 1. X plus y equals negative 32, and y equals 3x. So my first question, is there a variable that is already solved for? Yeah, y equals 3x. So I have y equals something. Does that make sense? Okay, so we are going to take that and plug 3x in for y. So kind of how I do it is I box or circle where I'm substituting so that you can visually see what's being replaced. And we're going to rewrite that first equation. So that first equation becomes x plus y. But y is actually what? 3x. So x plus 3x equals negative 32. And solve. What's x plus 3x? 4x. So 4x equals negative 32. And then how do I solve that really nice one-step equation? Great, divide by 4. So I get x equals what? Negative 8. Okay, that's just half of it. I have the x. What else do I need to get the answer? I need the y. So what I want you guys to notice is, does anybody see how convenient it would be to use y equals 3x? Because I already have y by itself here. So I'm going to choose that equation. You could plug this in to the first equation as well and solve for y. You will get the exact same thing, either way. Okay? But I always choose the one that is already solved for, just because then I don't have to do any adding and subtracting. I can just plug it in. So using my second equation, y equals 3x, I plug in negative 8 for x because I want to know what the y is for that x value. So what is y going to come out to? Negative 24. So x equals negative 8, y equals negative 24, and I'm done, yes? Wrong. It's not an ordered pair, so we need to write it as an ordered pair. Negative 8, comma, negative 24. Make sure you put parentheses around it. That's what makes it an ordered pair. Okay? I want you guys to work on number 2 right now. So, do I already have a variable isolated? Christian, do I already have a variable isolated? Yes, y equals 3x. Oh, that's convenient. It's the same as what we already use. Okay? So I'm going to take that 3x and I'm going to substitute it for which value, Melody? Y. Good. So here. So the new equation should be 3x equals negative x plus 8. Thumbs up. You're with me so far. Okay. I need to solve for x here. So what did you do first, Elijah?
I added the x.
Perfect. And that gives me 4x equals 8. And then what did you do, Megan? Perfect. And we get x equals what, ladies and gentlemen?
2.
X equals 2. Okay. Am I done, Kevin?
No, not yet. Not worth.
What'd you do next?
I plugged in
2 for which equation did you use?
3x.
3x? Okay, so y equals 3 times 2. Did anybody use the first one, just out of curiosity? Okay. You could have. And guys, what do I get for y equals 3 times 2? 6. So my ordered pair should be 2, 6. Thumbs up. You were good. Okay. Number 3, let's start this together, but then I'm just going to have you guys set it up, and then we're going to move on to something that's a little more challenging. Do I already have a variable that's solved for? Yeah. Isabella, do I already have a variable that's solved for? Yeah, I have y equals x minus 3. Or x plus 3. What is different? Who can tell me? What's different about this equation than the one, either of the other ones? Rose? Yeah, it has an x plus 3, right? So here's what I want you guys to do. Put parentheses around x plus 3. It all goes together, correct? So it has to stay together. So when I substitute that in, I get 2x plus 2 stays there. The 2 does not go away. And this is probably where students make the biggest mistake. They substitute the whole thing in for 2y, but we are only substituting for y. Okay, does that make sense? So it's going to be 2 times parentheses x plus 3 equals 38. What would I have to do before I can continue solving? Good, distribute. So we would distribute, combine like terms, and solve. Okay? I think you guys are good so far. Did anybody finish it yet? What'd you get? 8, 11. I think that's what I got too. Okay? Yeah, that's what I got. So I'll give you guys the chance to finish that on your own, but the answer should come out to 8, 11. Okay? Okay, a question like number 4. 3y plus 4x equals 11. Uh-oh. There are no variables that are already solved for. So let's look at the number 4. Look at both equations. Talk with your neighbor, come up with a plan. Is there a variable that seems like it's really easy to solve for pretty quickly? In either equation, it does not matter which. Is there a variable that seems like it might be easy to solve for? Anybody have an idea? Malika, what did you guys talk about?
I said that negative 2x plus y equals negative 13 would be easier to convert.
Okay, so she said that the second equation would be the easiest to work with. Thumbs up, you agree. I actually agree as well. And then which variable looks like it's really easy to get by itself, Jen? X or Y?
No, I used the second. I used the first one.
You used the first one? Okay, you can use the first one. Let me tell you guys what I'm thinking. Because I have like years and years and years and years of experience doing this. Notice how I already have a 1y. Does everybody notice that? Does that seem really easy to get by itself? What would I have to do to get that y by itself? All you would have to do is add 2x. And so then what I want you to do is I want you to rewrite that equation. So underneath I'm just going to write y equals 2x minus 3. Okay. Now can I substitute? Yeah. So put parentheses around the 2x minus 3. And we are going to substitute that value for y in the first equation. So here's what I want you to do. You do not continue working on the problem. I just want you to substitute in for right now. I know some of you worked ahead. Okay, so I'll give you a second if you haven't done so already. Substitute that value in, but I want you to check where you are with me before we move on. So when I substitute that value in, I should get 3 times y, but we're going to replace y with 2x minus 3 plus 4x equals 11. Thumbs up. You got this so far. Excellent. You can keep working if you have not done so already. Okay, guys. So here's my work for the rest of the problem. I distributed 3 and got 6x minus 9 plus 4x equals 11. Combined like terms. So 6x plus 4x gave me 10x minus 9 equals 11. I added 9 and got 10x equals 20, and then I divided by 10 to get x equals 2. Thumbs up if you agree with my work. Did I make any mistakes? Okay, and then we need to plug all of that back in. Now here's the nice thing about solving systems algebraically. I can use any of the 3 equations that are written at the top and it will still work. I can use 3y plus 4x equals 11. I can use negative 2x plus y equals negative 3. Or I can use y equals 2x minus 3. Myself, personally, I would use y equals 2x minus 3 because y is already solved for. So we've already done some of the algebraic math involved. So I would get 2 times 2 plus 3. So y equals 4 plus 3. Nope, it's minus. Minus 3. So y equals 1. Agree? So my ordered pair would be 2, 1. Do I have to put parentheses around it? Yes. Do I have to separate it by a comma? Yes. The parentheses are what make it an ordered pair, ladies and gentlemen. If you just write it out 2, 1, that just means you're listing numbers. Okay? The parentheses are what make it an ordered pair. Okay. A snack bar sells 2 sizes of snack packs. A large snack pack is $5 and a small snack pack is $3. In one day, the snack bar sold 60 snack packs for $220. How many snack packs did the snack bar sell? We need to identify our variables first. I'm going to let L equal the number of large. And S is going to equal the number of small. And this is where writing the system can get a little tricky. They actually give us 2 types of information here. They tell us how much money we made total, right? But then what else did they tell us? How many we sold total. So we're going to have one equation for the amount that we sold and one equation for the amount of money that we made. Okay? If L is the number of large packs that we sold and S is the number of small packs that we sold, what would I do to find the total number that I sold? Add them up, right? Does everybody agree? L plus S equals what? Hold for a second. 60. Think about it. The number of large packs plus the number of small packs should equal 60. So then we need to make an equation for the cost. How much did we make off of large packs? No, not 220. That was total. How much did we make just off the large ones? $5 each. So 5L plus how much do we make off of a small one? 3S. And how much money total was that? 220. Make sense? Okay, you should be able to solve the rest.